Now let us look at relative standing in box plots. So for relative standing measurement, we have z-score and percentiles. For z-score, is the number of standard deviation above or below the mean. So which is basically what we just calculate when we want to use the empirical rule, right? So it tells us how far a value from a mean in terms of standard deviation. So what you need to do is that you just use the value, you subtract the mean and divide by standard deviation. It will give you the z-score value. So the good thing of this is that it helps to standardize all data values. And after you standardize all data value, basically at that time it will make the comparison across data set become possible, right? Possible. Because we want to compare apple with apple, banana with banana. How can we compare these two, right? So basically, the one way to do that is just calculate the z-score. So let's look at this example, ant versus elephant. Which of the following two data values are more extreme relative to its corresponding data? A fried ant weighs 6 milligram, upper data with mean 3.11 and standard 7.49. So for this fried ant population, okay, the mean value is 3.11 and standard is 4.49, okay. And this ant is 6 milligram. And an elephant weigh up 14,000 pounds of the data with mean 12,000 pounds, and Sanderson is 1,200 pounds. So if you want to compare an ant 6 milligram with an elephant 14,000 pounds, it makes no sense, right? It just makes no sense. But here, we have a fair way to adjust, right? To see which one more extreme, right? Which you compare is to its own population, and then you by look at the z-score for each of them, and then you see which one more extreme. So basically, when you calculate this score for the fried ant, you see that he's 6 milligram, the mean is 3.11 and standard 4.9. So basically, this ant is about 5.898 standard far from the mean, right? And for the elephant of 14,000 pounds, he only about 1,667 standard for the mean. So from that, you can see that the z-score of the ant, this ant is much bigger than this elephant, right? So basically, the fried ant way here is more extreme relatively to its data. So this is the beauty of the z-score, right? You just standardize everything to its own data bulk, and from that, it makes this kind of comparison possible. So same here, right? Another quiz. Look at this quiz. Which is better? You do a score, you get a score 82 on a test where your friend, the whole class, right, you get a mean of 70 and standard an A, or in another test, right, you also score 82, which is the same, right? But in this test, your friend has the mean of 75 and standard deviation of 4, right? So whether they the same or one time you do better, compared to your friend, right? So this is the idea. Now think about that. Both tests you lose 82. But one test, all friends do that 80, 70, right? Standard 8. And another test, your friend do 75, but standard for 4, right? So the idea that again, just do this score, right? So for first test, right, we call Z1 here. It will be 82, subtract 70, right? Compare, divide by 8, right? So this case, you have about 12 divided by 8, you get about 1.5, right? For the second test, you got 82, right? You subtract to the mean, divide by standard deviation, right? How far from the mean in terms of standard deviation? And you got 7, and you divide by 4, and you got about 175, right? So which means this guy bigger, right? So which means the second 82 is better, right? Better. Even it's still 82, but compared to your friend, right? The whole class, right? I mean, because maybe different tests, it had a different level of difficulty, right? So this time you do better. So now let us look at percentiles. So percentile PK is help to separate the K percent of the data in the bottom, and 100 subtract K percent of data from the top. Okay, so K here 0, 1, 2, 3 to 100. So for example, P40 here is the value separate 40% of the data at the bottom, and 60% at the top. So say if you're high at a 40% time position, right? A P40. So which means that among 100 people, you're taller than 40 and shorter than 60, right? I say if you're high at an 80 percentile, right? So which means among 100 people, you're taller than 80 and shorter than 20. In special case of percentiles, we have quartiles. Quartile, which is, 25, 50, 75, right? So the first quartile, we know what P25 Q1, it separates 25% at the bottom and 75 at the top, right? And of course, here we short it, the value. And again, in this course, we just consider ascending order. Okay? Ascending order. Number keep increasing, right? And second quartile, which is B2, Q2, P50, okay, a median. It's separate the bottom 50 and the top 50%. Third quartile, Q3, P75. It says separates the bottom 75 and the top 25. Okay. So it's just a special case of the percentile at the 25, 50, and 75 position. So look at this example. Here the quartile age at death after 80 of 13 countries with good data. Okay. So people keep track data for people who are older than 80, and then what the age of death of those people. Okay. And in the period of 1950, 50, 50, 60, 60, 70, 70, 80, and 80, 90. Okay. So the first quartile is let's look at the first period. Okay. 1950. Okay. The first quartile Q1 82.08. The second quartile, the median is 84.46. And the third quartile is Q3 is 87.63. Okay. So here basically, if you look at this first row, right, you can see, for the period of 50 to 60, right, there are 25 people, right? That's before the age 82.08, and about 75 that's after that age, right? And same thing, 50 people among 100 people, right? Older than 80, 50 of them that's before 84.46, and 50 that's after that, right? And the same for Q3, 75 people that's before 87.63, and 25 that's after that, right? You can also look at the last period, right? 1890, right? You can see among 100 people, 25 that's before 22.6, and 75 that's after this age, and 50 that's before 85.45, and 50 that's after that, and 75 that's before 89.11, and 25 that's after that. So more or less, when you keep track this kind of data, you can see the tendency is that you see it increase. Right? People live longer, right? Maybe because you get a better healthcare, right? So one very powerful plot we also use is a box plot. Okay, it's used to show how data are distributed based on 5 important numbers, which is the 3 quartiles: first quartile, second quartile, third quartile, and the mean and the max. Okay, and box plots also help to show the outliers of the data if we have outliers. And the way we define outliers is any data value that are from Q3 which is the third quartile, plus 1.5 of the Q3 subtract Q1, or any value like less than the Q1, subtract 1.5 times of Q3 subtract Q1. And the Q3 subtract Q1 we call interquartile range, okay, interquartile range. And here in the figure here, just a box plot of a head circumference. So you can see that in this box plot, right, there's some the smallest one is I think from some animal is 10, right? The maximum is 250 millimeter, and the Q1 is about 70, right? Q3 is about 190, and the median is 130, right? 130. So for this specific data. So to create a box plot, basically, first you need to find important numbers. So the good news is that TI calculator can also help you to do that, while you put all the value in the list L1 and just also do one variable start, and you should be able to find all this value. And then after that, you need to identify the outliers. You need to check in your bowl cup data, is there any value bigger than the upper cutoff, which is Q3 plus 1 times 1.5 times IQR. And again, the IQR just a Q3 subtract Q1, or any value less than the low boundary, which is Q1 subtract 1.5 times IQR. Okay? And IQR here stands for interquartile range. And then your job is that, for the outlier, you just do an asterisk, right, of them. And then you draw a line connects smallest value to largest value, not outliers. And then you draw a box from Q1 to Q3, and then a line straight through Q2. Okay. So here outlier we already put in asterisk, right? So we look at this problem, okay, which was well developed in terms of coding and how this box plots were constructed, right? So here are the weekly salary box plots here, okay? So we have 14 employees. Their weekly salary in dollars at this given, right? 460, 470, 750, okay? So if you plug in all this value in your calculator, you can get the file summary number at 460, the mean, the max 4,500, first quantile 790, second quantile 905, and third quantile 1320, okay? And the maximum is 4,500. Of course, you can also do it by manually look at this, right? But I would recommend just use the TI calculator, okay? It's safer, right? Because, sometimes in the test, you have time constraint and by overlook a number and just for, you make a wrong choice. So from that, you can get in the quarter range, which is Q3 subtract Q1, which is 1,320, subtract 790, and you got 530. And the outlier is the one who bigger than 1,320 plus 1.5 IQR, right? So any number bigger than 2115 or less than the Q1 subtract 1.5 IQR. So in this case, you get -5. So basically, for this data set, you have one outlier, which is 4,500 here. So you put it as asterisk here. So what you need to do is you look at the mean, which is in this case 460, right? And the max, which is not counted outlier 1,500 in this case. You strike two lines here, which is you put here. Okay, eventually you can strike two lines at the beginning as well, and then you construct a box, right? Which is from Q1 is 790 to Q3 is 1,320, right? And you try middle, which is median here, 905 here. So you got a box here, and you got two whisker here, right? And you can do the bar here, And sometimes people, they don't do the bar at the min and max, but it's up to you. Okay, it's up to you. In this case, they do yeah, they do, right? But sometimes they don't do it. So the relationship of the percentile and the data value for sorted data in the ascending ascending order again for this class, the default is ascending. Okay, with n observation, given a value x, basically we do care about what's the pk tied to x, right? So what the percentile tied to x, right? So in order to calculate the pk, so basically your k can be calculated by using the number of values less than x divided by n, which is the sample size. So say, basically like for this question, like, say my salary, right? My annual salary, say maybe 60,000 a year. I wonder where I stay in this bulk of people, in this county, right? So what I need to do is that I need to find out all the people who make less than me, right? And divide by total. So this is my K. It will give me where I stand, right? And here like another question in the backward way, right? So here you know the percentile, and you wonder like what's the value x tied to pk, right? So look at the country, right? You wonder what's the median income of the country. So basically like what is the P50 of the country, right? Yeah. Or maybe what a median height of people there, right? So in this case again, given P50, what is the x, right? Tied to P50. So in order to get this x, right, what you need to do is that you need to find the h value from the left, where h is calculated by k times n divided by 100. And we do the cap here. So the cap here, basically, upper cap here, basically, it's just the closest integer that greater or equal than x. So example like we call it cell, okay, the cell. So the cell of 11.7 is 12. The cell of 12 to 12, right? But remember the cell of 11.1 also 12. So you sell it, the closest integer that greater than equal to x, right? But the cell of 11 only 11, right? 11. So this is different with round function. The round function, you just take thing from half, right? To make it up, right? But this guy, as long you have a decimal, you make it up. So let's look at the example about Arctic temperature, okay? So in this case, we have a real data from different station, okay? 7 station in Arctic, okay? So we have both temperature in Celsius and F, okay? In ascending order from lower here, Greenland to the upper one, which is Murmansk. So in Greenland, the average annual temperature is negative 28.1 or negative 18.4 F. In the Murmansk, which is 32 F. So the pk, the percentile of the value, negative 16.2, which is corresponding to Canadian per year here. You can calculate it by find a k, right? Which is you have two value less than this value, which is this guy and this guy, right? And divide by the total by is 7, right? So basically this is corresponding to the 29 percentile value, P29. Okay. And then again, you can also find backwards. So you curious what is the value type of the 29 percentile for this data, right? And then you use it formula. First, you need to find the H index by using K times N by divided by 100. And you save it, you got 3. And basically, this is corresponding to the third value. And third in the ascending order, which is, again, it gives you back negative 16.2, okay? So for a small data set, sometimes you do forward and backward this way, you see a little bit different. But for the large data sets, you have more observation, maybe 50 or something. This kind of phenomenon will eventually resolve itself. But for this case, we're lucky because we have it matching. Okay, but don't be surprised when it's not much. Say if you get from a temperature, you get a pK, you get different one, maybe P29, but from P29 you calculate back and you get something else. So it sometimes it happens with small data. But for this not the case here. This is just some thing I want to give you a notice in advance in case you encounter such a situation. So don't be surprised because basically like when your data set is too small or the relative ascending position it have some fluctuate there, but it will be removed when you have a more data available. So let's look at this quiz together. Box plots for weights of the test score of a group student given by here. Okay, so here we have box plots of test score. Okay, of test score. Test score. Okay. Okay, so you get like box plots and the mean is 0, the max is 13, and there's some tests. Okay, the max is 13. And the median is 10, the first quartile is 2, and the third quartile is 12. Okay. So the question here is the first one, which quarter has the smallest and largest spread of the test score? So we have 4 quarters here, right? Q1 to Q mean to Q1, Q1 to Q2, Q2 to Q3, and Q3 to Q4. Okay. So you can see like the largest spread where? This quarter, this quarter, this quarter, and this. So largest will be this guy, right? 25% of the data, the spread is about 8, right? 10 subtract 2, right? Is 8. 8, right? So largest spread. Smallest one is the last quarter, right? 13 subtract 12 is 1, right? The range is 1, right? Spread here, you range to represent, right? Now the largest is the quarter from Q1 to Q2, and the smallest is from the Q3 to the max, right? And the largest will be from Q1 to Q2. Find the IQR, which is interquartile range. The interquartile range we define by using the Q3 subtract Q1, right? This is the definition of interquartile range. Q3 subtract Q1. So in this case, the Q3 will be 12, right? And subtract Q1, just 2. So interquartile range is 10 in this case. So the last question is that, are there more test scores in the interval from 5 to 10 or in the interval from 10 to 30? How do you know that? How do you know this? Think about it. 5 to 10 or 10 to 30. Which part has more test score? So you can see that from 5 to 10, all the score here, it will belong to the second quarter, right? Because second quarter from 2 to 10. So basically, that you should have your test score about less than 25%. Your test score belong to 5 to 10, right? But for the interval from 10 to 13, it's included 2 quarters, 10 to 12, 25% of the data, and 12 to 13, 25% of data. So basically, you have 50% of data. So here you have about 50% of your data, 50% test score, and here you have less than 25%. So basically, you can see that the interval here will have more test score, right? 10 to 13. Because about 50% of your data fall to this interval. But for the interval from 5 to 10, you have less than 75%. So from here, you can see that even, you have a longer range, right? From 5 to 10 compared to 10 to 13. But most test score focus on this segment, right? 10 to 13. So this quiz also close the chapter here. So thank you so much for your attention. And I'll see you in the next chapter, chapter 3, probability.